All right, so these are the notes for 4.1. We are wanting to be able to interpret the meaning of a derivative in the context of a story problem, and your homework is going to be worksheet 4.1. So first thing we want to notice is the temperature in degrees Celsius. So we need to know temperature is in degrees Celsius, C, of the water in a pond is differentiable function. So we know it's continuous. So as soon as they said C is differentiable, it says function of W, we need to say W is continuous because W is differentiable. We want to write that, even though it's not needed on this problem, it's needed on a different one. The table to the right shows water temperature as recorded every 3 days over a 15-day period. So we need to notice that we're talking days. Use the data in the table to find the approximation for W prime at 12. Well, we need to know that W prime of 12 is going to be the slope of W. So we need to find where T, time is 12. Well, so we got 3 different options here to use. We can use any one of these 3 we want to use, and we can use 9 and 12, 12 and 15, or 9 and 15. Doesn't really matter which one we use. I'm going to use the one on each side of 12. So I'm going to use this point and this point. I could have used any one of these 2, those 2, or the ones I'm going to use. So I need to know that I need the slope. So I'm going to get 24 minus 21 all over 9 minus 15, which is going to end up being 3 over negative 6, which is negative 1/2. Now, we need to know that this top part is Celsius from this thing. So this is Celsius, degrees Celsius. And down here, this is days. So when we write this answer, this is negative 1/2 degrees Celsius per day. So that's the answer to that problem. Now, what if we were asked to interpret the meaning of this approximation? And again, this is an approximation. I should have put squigglies, but it's not wrong if you don't. Found example 1, and we want to use the acronym NUT to remember how to do this. So if I move this thing down, we need to say a noun of what we're talking about. And we need to use U as the units, which we've got the units right here. And then we want to include at which time. So that 12, the 12 that's up here at the time. So we want to say this is the temperature of the water is changing at, or is changing by, about, I'm going to use the word about. If you don't put about, it's okay. Negative 1/2 degrees Celsius per day at T equals 12. And we'll probably ought to put days, 12 days, at T equals 12 days. Okay, so that would be the interpretation of this object, or this problem. Okay, we're going to go on and do another one of these. So over here on this side, we're going to want to do this problem. And these are, by the way, these are all AP test questions from old tests. If you look, it tells you this is 13, this is question AB, open-ended problem. On a certain workday, the rate in tons per hour. Okay, so this is already a rate. It's already a first derivative, basically, because tons per hour is a rate, at which unprocessed gravel arrives at a gravel processing is modeled by this. So this is the rate in tons per day of this object, where T is measured in hours. So we're going from 0 to 8 hours at the beginning of the workday. The T equals 0. The plant has 500 tons of unprocessed gravel during the hours of operation from 0 to 8. And again, remember T is hours. The plant processed gravel at a constant rate of 100 tons per hour. Find G prime of T. So this is a calculator problem. So we're going to do this on a calculator. And it tells you over here, finding G prime of 5 is one of the things you have to do. So by writing this, some of you on the last test did not tell me what your answer was, and you wrote an answer, and I put no bald answers around allowed. So you have to tell me you're finding G prime of 5. So I'm going to get my calculator and show you this. Now I've already typed these into the calculator because I wanted to save time on this problem. So I'm going to show you that when I turn this on, I have these problems already turned on. This, the one at the bottom is the next problem. So I want to use that top one, so I just turned off that second one. Now I'm going to hit second quit, and I want G prime, so that's going to be math 8, which is derivative, and I use X, so it's going to be X. Now I type that into Y1, so I'm going to hit vars, arrow to Y vars, hit enter because of or 1, and then that's where it's stored. I hit 1 again. And then we want this when X, and that's what the time was, it said 5. So we're going to type 5 there and hit enter. So right there, negative 24.5875, blah, blah, blah. That is the thing that I need to use. So we're going to come back over here, and we're going to say that that is equal to, and we have to round this to 3 decimal places in this class, at least 3. You can go further. So I'm going to round that to 585. Now, this is the slope of this rate of G of t. Now, if G of t is already tons per hour, so this is tons per hour. That is the y value, and then over the x value. Well, the x value is hours, so we can write it like that. So this is negative 24.585 tons per hour, which you can also write as tons per hour squared. You can write it like that because this is over 1, and you flip that upside down, and that's where the hour squared comes from. Now, that is not the interpretation. That is the answer. So now we want to interpret that. So what we want to say is, again, we're going to use nut. So we're going to say what we're looking at is the rate, because it says at the beginning of the workday, during the hours of the plant, interpreter. All right, where does it say? We were looking for G prime, so we are looking for a rate. So the rate at which the gravel is arriving, the rate at which the gravel is arriving, that's my noun, the gravel, the rate of the gravel arriving. I'm going to say instead of arriving is changing. We're going to say arriving. Arriving is changing by, because it's a rate, we're changing by negative 24.585. And again, I could have put around or approximately tons per hour squared. And if you wrote tons per hour, you would be fine. And it would say at t equals 5 hours. And that would be the interpretation. Again, it's 5 because of that 5 right there. That's when it was 5 hours, the instantaneous rate of change is that. We're going to do one more problem here that's from an old AP test question. So when we do this one, this is from 2007, so this is an older one, but we still usually have these kind of problems on there. I'm going to move this down a little bit. This says the wind chill is the temperature in degrees Fahrenheit a human feels based on the air temperature in degrees Fahrenheit and the wind velocity in miles per hour. So wind velocity in miles per hour tells me that this thing right here is a velocity function, I guess is the best way to put it. If the air temperature is 32 degrees, then the wind chill is given by this function right here and is valid from velocity of 5 to 60 miles per hour. Find W prime of 20. Now this is W, so W prime, this thing is going to be a derivative of this function right here. And remember this wind, the W, wind velocity, the W is for the wind, it is already in miles per hour. So it's already a rate, and then we're going to do the derivative of that, which means the slope. So this is going to be another one that's miles per hour per hour. So I'm going to get my calculator and bring it over here so you can see that what I typed in my calculator here. So let me bring this thing back over here. So if you recall a second ago, I had the equations here, but now I need the second equation because I think that's the right equation that I had. So I turned that on by hitting enter and making the black highlighted. I got the equal, so I'm going to hit second, quit, and I'm going to hit math 8 again. So there's my math 8, and I used X instead of V. I'm using X. And this says we want it at W prime at 20. So this is in Y2. So I hit vars. I arrow the Y bars. It's a function. I hit 1. But now I got to go down and hit 2 to get Y2 in there. And I wanted that when the velocity, or the V was 20. So I put 20 in there and I hit equal. And there is the answer, the approximate answer of that problem. So now I got to move this back out of the way here. And I'm going to write that answer in up there, and then I'm going to write the interpretation of that answer. So when I write this answer, I'm going to say W prime of 20. Again, I must tell them what I'm giving them. If I don't tell them W prime of 20, that's called a bald answer, and you will lose points just like you did on that test. So this is negative 0.286. Again, this is a slope of this miles per hour. So this is miles per hour per hour. And again, that could be written as miles per hour squared. Okay? And you can put miles here, and you can make this hours, and you can make this hours. Okay? So that is my answer. Now I'm supposed to interpret that. Now, what are we talking about here? We're talking about the wind chill, how the wind chill is changing. So we would say the wind chill is changing at a rate of negative 0.286 miles per hour at t, I'm sorry, I shouldn't use t because it's not t, it's not time, it's velocity. You remember velocity at v equals 20 miles per hour. So that would be the answer to this problem. So that's kind of how you're going to have to interpret these problems. Hope you have a great day and get this homework done, and I will see you tomorrow.